Okay, average rate of change questions. Here we go, average rate of change. Okay, now this is just like doing slopes of straight lines. So if you think about slope as rise over run, the change of y, the difference in y over the difference in x, then we can look at it like this. Okay, 1980. Population was 6.8 million. 1992. Population had grown to 9.5 million. Okay, so we can think of it like this. Let's say this is 1980 and this is 1992. So in 1980, let's call this 6.8 million. In 1992, let's call this 9.5 million. So what we have here is, if you think about it, the difference in y over the difference in x will give you this, right? 9.5 minus 6.8 all over 1992 minus 1980. Okay, and that equals, what's that going to give you? That's 2.7 over 12, and I suppose if I put that in my calculator, so a little edit there, if I put 2.7 divided by 12 in my calculator, I will get 0.225. So what that means is, in terms of millions, alright, that's 0.225 million people per year increase in population, or if you think about it, that's 225,000 people per year. Okay, right, here we go, next one. Find the slope and the y-intercept of the equation. Now this is going back to something we looked at earlier in one of the videos, and that is, if you're going to graph this by intercepts, then you can just set x equal to 0 to find the y-intercept, or y equal to 0 to find the x-intercept. But supposing we actually want you to rewrite it in the form y equals mx plus b, so I can see what the slope is, the m, and I can see what the y-intercept is, the b. Okay, so I need to find the slope and the y-intercept. Okay, so I need to find what y is by itself. So I'm going to take away this 3x. I need to get rid of the 3x and I need to get rid of the 5 that's around this y. Take away 3x. Okay, so I've still got the 5y, but I now have 10 minus 3x, because I took away 3x from that side as well. Okay, again, I took away 3x from both sides. Now the next thing, can you see, is to divide by 5. Okay, divide everything by 5. Everything by 5. Okay, so you're going to have y equals 10 divided by 5 is 2, and just write that as minus 3/5 x. Now this is kind of written back to front if I want to write it y equals mx plus b. So finally y equals, put the negative 3/5 x first with a plus 2 second. So I can clearly see now that the slope is negative 3/5 and the y-intercept is 0,2. Don't just write 2, it's 0,2. Okay, so that's how you rearrange the standard form to the y equals mx plus b, the slope-intercept form. Okay, get rid of the x, divide by the number next to the y, and onwards. Okay, right, slope of lines, equation of lines. We are going to use m equals y2 minus y1 over x2 minus x1 to figure out what the slope between these 2 points is. Then I can use y equals mx plus b to figure out what the actual equation is. Okay, so let's call this x1 y1, this x2 y2. So here we go. y2 is negative 33. I'm going to take away y1, which is negative 43. So watch the two negatives there, okay? That's what I'm doing for the numerator. The x's, x2 is 8. Take away x1, which is 10. So I'm going to get negative 33 plus 43. That is going to give me 10. Okay, negative 33 plus 43, remember, two negatives. 8 take away 10 is negative 2. Looks like the slope is negative 5. That's what m equals, okay? Right, great, okay. But I now need to find the actual equation of the line. So what you do is you can use, now you've got the m, you can stick it in here, alright? But also I need an xy coordinate, and it doesn't matter which one of these two I use, I'll end up with the same answer. I think I'll just use this first one, okay? So what I'm trying to say is this. Y is negative 43, so negative 43 equals, I'm just using y equals mx plus b over here, okay? The slope is negative 5. The x coordinate is the 10 here. I'm just using 10, comma, negative 43. 10, okay? And then plus b. Okay, so the only thing that's missing is me to find the y-intercept. Right, negative 43 equals negative 50. That's what 5 times 10 is, plus b. Can you see, to get the b by itself, I would add 50 to both sides. Add 50 over here, and you're going to get 7. So b equals 7. Now put it all together, this and the slope, and you get, find a space, y equals negative 5x plus 7. Okay, and there you go. That's the equation of the line. There is another way of doing this. I'll quickly go back and run through this again. So look at that. You need to pause it, hold it. Great. I'm going to go back here. I'm going to erase this. Okay, because the rest is just the same. I'm going to do this. Right. Instead of putting it into this y equals mx plus b, I'm going to put it into the point slope formula, which is this, y minus y1. So I'm just doing two different ways of doing it. Okay, we tend to use a lot of the point slope formula and not just put it back into y equals mx plus b, but you're going to get the same answer. Okay, so again, here we go. So this is the point slope formula if you need to look it up. Y minus, I'll go back and use this again, this xy coordinate again, the 10, negative 43. So negative 43 is the y coordinate I'm going to use. Okay, so again, looks like I'm going to have two negatives there. Equals m, which again is down here, the negative 5. Again, x minus the x coordinate, which is 10. Again, I'm just using that 1 point. I had to use 2 to find the slope. So we have y plus 43 equals, do the distributive law, negative 5 times x is negative 5x, negative 5 times negative 10 is positive 50, and again, if I take away 43 from both sides, hopefully you're going to see, take away 43, you're going to get 7 there, you're going to get exactly the same answer as what I got just by putting everything into the y equals mx plus b formula. Okay, so two ways of doing it. You can either put some numbers back into the slope-intercept form, or put it back into the point slope form, which is usually the preferred method, but they both come up with the same answer.